Good day and welcome everyone. My name is Janeline Shigela Yandug and I'm from the School of Industrial Engineering and Engineering Management of Mapua University. I'm here to present our paper entitled Simulation-Driven Appointment System Model for a License Processing Office in the Philippines. Along with the increase in the number of cars and roads being used for personal transportation is the increase in the demand for driver's licenses. In the Philippines, the issuance of driver's licenses and renewals are under the jurisdiction of the Land Transportation Office. There are three types of driver's licenses, which are student's permit, non-professional license, and professional licenses. And based on data, NCR has handled the most license cases with 26.6% of the total issuance. Since not all branches handle the issuance of licenses, as a result, more transactions are being held in the other few branches. That's why many people complain about getting their driver's license, which is spending hours of waiting to complete the process. The overall waiting time of applicants make up an average of 64% of their time spent in the process. This results to sudden announcements to come back again some other day and at a much earlier time to continue the process. Therefore, applicants become more dissatisfied and disappointed with the system. Other government offices have long adopted the scheduling approach to shorten waiting times and length of the queue in the office, while the Land Transportation Office still follows the simple rule of first come, first served. So it is the objective of the study to reduce the total waiting time by at least 25% and ensure the completion of the application process within a day. To achieve this, the study aims to design a batch scheduling for the application of appointment system and to evaluate different scheduling rules in the setting of LTO. The study was done by first observing the current system of the office. Process starts when the applicant must first visit the customer service window for validation of IDs and get the application form for a new driver's license. After filling up the form, the applicant will proceed to the medical testing area to have his or her vision and hearing tested. Any medical test from an LTO-accredited medical testing centers are accepted. The medical testing area is not part of the LTO, so it is not included in the time study of the process. After the test, the applicant will go next for the verification, picture, and signature taking. This takes an estimate of 1.5 minutes. The next step is to go to the cashier to pay for the transaction fees. After that, the applicant can now go to the lecture and examination waiting area for his or her name to be called before he or she can enter. This step is supposed to be done by batch of 25. Applicants are given 120 minutes to review in the lecture room, and when the time is up, they will be called to enter the examination room and take the multiple choice test. Applicants can take the exam for 120 minutes, but are allowed to submit their papers before the time. The papers are forwarded by batch to the checker, where it will be checked by a machine. If they pass the examination, the applicant will proceed to the practical driving test area where their skills in driving are tested. Then, the approved applicant can now pay at the cashier once their name is called to pay for their driver's license. For the cashier, the documents are forwarded to the releasing window to process the driver's license. The newly registered drivers will wait until their names are called to pick up their driver's license at the releasing window. The model was formulated starting with the creation of the layout of the licensing office to see the flow of events. And the three kinds of applicants were considered: new, renewal, and student permit, which served as the entities. The number of arriving entities, their time of arrivals, processing times for each of the stations, and the sequence of going to the stations were entered in the model as well. To prove the accuracy of the simulated model, a t-test was completed to determine if there is a significant difference in the actual system and the model's total process time. Results show that there is no significant difference between the times acquired through sampling and the system times resulting from the Pro model. Thus, these analyses of variance assure that the model can very well represent the real situation and accurate enough to be reliable in producing realistic and accurate outcomes. Improvements on the system were simulated in the Pro model. A call-based appointment system was introduced, wherein applicants can call the nearest LTO branch and give their selected time of arrival based on the appointment schedule and the quantity. In appointing the arrival time of the applicants, the aim was to lessen the queue lengths as short as possible, and this could only happen if the arrival times were varied to prevent them from coming at the same time. A combination of varying batch arrival size and accumulation quantity was simulated to see their individual and combined results. Results showed that an arrival size of 5 and accumulating 5 applicants at each step in the process results in the shortest waiting time of 34 minutes, thus making this accumulation size the best option in standardizing the system's internal procedure. Changing the sequence of the application process was also evaluated if it has significant effect on the reduction of waiting time. Stations that cannot be interchanged and must be consecutively sequenced were also taken into consideration. With all factors consistent and applying this change of route, from the normal average waiting time of 112 minutes, it was reduced to an average of 83 minutes, showing a significant difference of 29 minutes. The simulation time or running time of the process also decreased from 8 hours to 7.88 hours. The final model consists of the following improvements: standardizing the batch processing to a maximum accumulation of 5, 14 minutes of inter-arrival time per batch, and changing of the route. These are the results of selecting the best time based on the following performance measures: the total running time, or simulation time, the average total time, and the average waiting time. The model was run and replicated 15 times to check its precision and accuracy, as well as verify its stability. With a 90% confidence level and within the allowable error of 5%, the required number of samples was determined to get a reliable mean of 1. Thus, having performed 15 runs is enough to prove the effectiveness of results acquired in the study. An appointment system can only be affected by the degree of lateness on the arrival of applicants, so it is important to consider the applicant's natural lateness. The table shows the comparison between the proposed system and its variation considering different instances. The first case is having a delay by 1 hour in the arrival of the first batch. Thus, they all accumulate in the second hour. The second case is maximizing the longest step in the process, which is the examination. It was maximized to 1 hour for all applicants, resulting in finishing the test by members of a batch at the same time. The third case is having a delay by 1 hour in the arrival of the first batch and the last batch. The best models chosen were all from accumulating 5, while varying arriving batch quantities, which were 5, 8, and 10. So to conclude, in a system where applicants arrive on their preferred schedule, the possibility of being asked to come back on the next day or not being accommodated at all can likely happen. Unscheduled arrival also renders applicants to longer process and waiting time. In the improvements being proposed in this study, with the same quantity of applicants being accommodated, application and evaluation of different scheduling rules were simulated on the process by varying the arrival batch size, accumulation size, changing the arrival sizes depending on time, and changing the distribution of arrivals in these schedules. Thus, the time in the system was reduced by evenly distributing arrivals, giving room for more applicants. The study was able to decrease the waiting time by more than 25% and ensured the completion of the process on the same day of starting the process. That's all, and thank you for listening.